Okay, so when we talk about nth roots, roots that you're familiar with right now, by the way, this is section 3.1, are square roots. Okay, so for example, if I had the square root of 25, I'm looking for a number that times itself 2 times to give me 25. Okay, of course we know that that's 5 times 5 is 25. But what you don't know is there's an imaginary 2 that sits here in front. It's kind of an implied 2. And you know, with math we have a lot of implied things. If we have a variable without a coefficient, we know there's a 1 in front. If we have no exponent on something, we know that it has an exponent of 1. So now if you see a square root, you know that it has an implied 2 there. So the question is, can that number ever change? And so the answer is yes, it can. For example, we could have the third root of 125, and what that's asking is that's saying, okay, what number times itself not 2 times this time but 3 to give me 125? So I hope you're familiar enough in your math career at this point that you can say, wait, I know that 5 times 5 times 5 gives me 125. So the cubed root then of 125 would be 5. So oftentimes what we'll do is we'll call these nth roots. Okay, so we'll put a little variable n out here and we'll put a number under the radical. So that this would be the nth root of a. Okay, now the n of course tells us what can I multiply, what multiplies by itself n times to give you a, which is here under the radical. Okay, so if I had the fourth root of, let's say, 16. Okay, I'm asking myself now, what can I multiply 4 times to give me 16? Okay, so these you have to kind of think about these a little bit. This would be, of course, 2. Okay, so I want to give you a couple to kind of think about here. The first one I'd like you to think about is, how about if I asked you what the third root of 216 is? So take a minute and see if you can figure this one out. I hope you figured out that the third root of 216 is actually 6. Okay, that 6 times 6 is 36, and then times another 6 would give you 216. Now, let me show you something else, and let's think about this for just a minute. We know that if we have a negative number under a square root, let's say the square root of -4. Okay, so I want you to think about something with me for just a minute. If I had the square root of -4, I can't have the square root of a negative number, because what happens is I can't find 2 things that multiply together to give me a negative number that both have the same sign, right? So this is where we pulled out the I, and so we ended up with plus or minus 2i, right? However, it's a little different if I'm talking about a different root. For example, let's say I had the third root of -8. Well, this time, can you think of 3 numbers all exactly the same that multiply to -8? And I hope you would say, well, wait, 3 negatives multiplied together, this would give me +4, would give me a negative number. So now, the point that I'm trying to drive home here is even roots. Okay, if you have an even root, you can't have a negative under the on the radical without the imaginary, okay? However, with the odd roots, okay, any odd root, you can have a negative, and the answer just keeps that whatever sign was under there, okay? So your answer keeps the sign. So if I had the one we did a minute ago is the cubed root of 216. If that was the cubed root of negative 216, I could do that. That would be negative 6 instead of positive 6. Alright, so let me give you one more to try here. Let's try, you evaluate. Remember, if I'm talking about the nth root of a, I want you to find if n equals, let's say n equals 5 and a is negative 32. Find that value for me real quick. Okay. I hope that you have figured out that the fifth root of negative 32 would give you negative 2. Now I do want to take just a second to show you a little shortcut on your calculator. Alright, so I want to show you how to put this on your calculator. So if you look, if I've got the fifth root of negative 32, on your calculator, if you enter the root first, so I'm going to hit 5, then the math option, and if you see that option number 5 is x root, if you go down and select that one, okay, and then do negative 32 and enter, what it will do is it will give you that value. So you can enter any root on your calculator using your calculator. Of course, easy roots I would like for you to be able to do without the calculator. And just to show you, remember I told you that you couldn't do even roots of a negative number without getting an imaginary. So if you look, if I do try, my calculator will give me an error there. So nth roots are pretty easy for the most part. And so we also have another easy concept, which is rational exponents, okay? So you're going to kind of rethink radicals for a minute, okay? Any radical can be written as an exponent. Now what I mean by that, can be expressed, we'll say expressed instead of written as, expressed as an exponent. So what I mean by that is if you think about, let's just take the square root of x, okay, we'll just put an x under. Now remember, there's some implied numbers in this, okay, because there's no root indicated here, there's a 2. Now be careful because this and this are two totally different things. Those do not equal, okay? This is asking for the square root of x. This is asking for 2 times the square root of x. So completely different as you look at those. So make sure your number's written very little up here and kind of sits in the radical. All right, so that's one implied number. The other implied number comes as an exponent on the variable itself, and that's a 1, okay? So I told you any radical expression can be written as an exponent. Rational numbers are fractions, so I can change this to an exponent of 1 over 2. So this number is always the denominator of the fraction, okay? And this number is always the numerator. Okay? So for example, if I have, let's say, the third root of 5 to the 4th, and this number, this 4, can be written here, or it can be written here. Okay, those are both the same thing. This is called radical form, okay? But I can change it to rational exponent form by taking the base, okay, 5, and changing these numbers to an exponent. So it will be 5 to the 4 over 3. And this is again called rational exponent form. Okay? So to be successful here, we have to be able to smoothly transition from one form to the other. Let me show you what I mean by that. I'm going to give you a couple in radical form and a couple in rational exponent form, and we're going to work with those and see what happens. Let's say I had 16 to the 3 halves. Okay. If I want to change that to radical form, because right now it's in exponential form, I'm sorry, rational exponent form. The bottom number is the root, so it's the second root of 16 to the 3rd power. Okay? All of a sudden this becomes easy to evaluate, because I hope you know what the square root of 16 is. That's 4 to the 3rd power, which is 64. So it makes it easy to evaluate also. Let's change forms of another one so we can kind of get the hang of this. Let's do 32 to the 3/5. Okay? Bottom number, that is the root. And then the exponent is the 3. Okay? And the reason I'm putting it on the outside here is because I recognize that the 5th root of 32 is something that I should probably know, and it is. It's 2 to the 3 over 5. Again, denominator, numerator. Okay? So a lot of these are easy to evaluate if we change the form on them. Okay, so one more. Let's do 9 to the negative 1/2. So here we got to think about some of those exponent properties, okay? That negative, of course, flips, makes it go to the bottom. So now let's change the form, okay? And this is the square root of 9, and of course we all know the square root of 9 is 3. So I know you can do these on your calculator, but I really want to see the steps you get to in order to get there, okay? So let me give you one to try. I want you to change the form and then tell me what it equals. Evaluate it once you change the form. Let's try this one. And tell me what you get. So I hope you changed the form and got the 4th root of 81 to the 3rd power, okay? The 4th root of 81 is 3, and then 3 to the 3rd power would give you 27. Now, I told you you could use your calculator, and you certainly can use your calculator for a lot of this. I do want to see your steps as you go through, and I want to see how you work. However, for some of them who aren't perfect roots, it's kind of hard sometimes. So I do ask you to evaluate and use a calculator when you do. So I just want to show you quickly a couple examples using your calculator and make sure you can do it. So if I've got the 3rd root of negative 30 to the 2nd power, okay? First thing I want to do is I want to do that 3rd root, okay? So I'm going to do 3 math x root and then do negative 30. Remember, this is an odd root, so I can do a negative under the radical. You can hit enter to get that value, and then at that point I'll go ahead and raise it to the 2nd power, okay? So it's approximately 9.65. Now to enter in a rational exponent, and just be very careful, and I know you probably know how to do this, but just to make sure you know how to use your calculator to evaluate these. I want to do 64, okay? I'm going to raise it up. Remember, if I have a fraction, I really need to put it in parentheses. So I'm going to do parentheses, negative 2 divided by 3, and I get 0.0625. Okay, so let me give you one to try. I want you to evaluate 4 to the 2/5 using your calculator. Now I hope that you have gotten that at this point, and when you do input that, you get approximately 1.74. Okay. One more example for you to try. Let's try the 4th root of 16 to the 5th and tell me what you get. As we input this one on the calculator, remember I want to do the 4th root, so I do 4 math x root 16, hit enter, and then you can raise it to the 5th power. Okay, you get 32. This one you probably could have done on your own, but just to make sure you can utilize the functions on your calculator here, okay? One final thing here, solving equations involving roots, okay? Now I want you to think about something with me for just a minute. If I have x squared equals 15 and I want to solve that, well, we know that opposite operations are what cancel out certain things, right? For instance, when I'm solving an equation, the opposite of addition would be subtraction. If I am multiplying, and of course these go both ways, if I am multiplying, then the opposite of that is division. If I have an exponent of 2, we talked about the opposite of that to cancel it out is the square root. So here, to solve this equation, I would do the square root on both sides. Okay, that square root and that squared cancel each other out. So to solve this, I would have the square root of 15. Now, the question becomes, what if the exponent is bigger than 2? What cancels that out? In other words, if I had something like 4x to the 5th power equals 128, okay? We know that opposite order of operations is going to take us through, and we would divide by 4. Okay, easy peasy. X to the 5th would be 32. But the question becomes, how in the world do I get rid of this exponent? Okay. Well, if you think about a squared and a square root has an imaginary 2, I hope it follows for you that if the exponent is 3, I would take the 3rd root. If the exponent is 4, I would take the 4th root, and so on and so forth. So to get rid of a power of 5, I could do the 5th root. This is gone, and I end up with x equals, and then the 5th root of 32 is 2. Okay? One more, a little more complicated to try. How about, let's do x plus 5 to the 4th power equals 16. Okay? Against that, maps in my parentheses are last, so what I want to do is get rid of this exponent. Okay? Exponent of 4 needs a 4th root to get rid of it, and if I do it to one side, I must do it to both. Now here's where it's going to get a little tricky. Because this is a 4th root, that's an even root, this is actually plus or minus 2. Okay? Remember, odd roots keep the sign, even roots plus or minus, and it's got to be positive. So really what this says is x plus 5 is 2, or x plus 5 is negative 2. And then of course I have a one-step linear equation. I can subtract 5 and know that x is negative 3, and I can subtract 5 and know that x is negative 7. Let me give you one to try here, and then we'll come back and do it together. Let's try 1/2 x to the 5th equals 5/12. So as you solve this, of course, to get rid of that fraction, we're going to multiply by the reciprocal here. Cancels out, so I have x to the 5th equals 1024. Fifth root will cancel out that exponent, and I'm not 100% sure about the 5th root of 1024, so I'm going to use my calculator and do the 5th root of 1024, and I get 4. I don't need the plus or minus here because it is an odd root. Okay, and that's all there is. Nth roots and rational exponents.